What's up, guys? Welcome back to November 2023 exam paper for grade 11. Now let's have a look at question number 4. It is divided into 3 questions, 4.1 with 3 questions right there, and then we also have 4.2 as well with 3 questions, and then we also have 4.2 with 4 questions. All right, let's see how does this question look like. A very interesting question indeed. You might want to stick around until the end of this video so that you fully understand what is happening in this question. If you have a question or there's something that you don't understand, let me know on the comment section below. If you haven't subscribed, please make sure that you also subscribe. All right, let's see in the diagram below the first 3 figures in a pattern that Mary is investigating. It's shown below. We can see there that we have got 4 dots, and then we have got 9 dots, and then the other figures has got other dots as well. All right, it says here on this question here, it says that we need 4.1.1. It says here we need to determine the total number of squares in figure 5. Okay, let's come here at least and see in figure 1. This is figure 1 here. Let's see how many number of squares are here. We only have 1 square. And then here, how many squares? 1, 2, 3, 4. We have got 4 squares. And then how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have got 9 squares. So they want the number of squares in figure number 5. So it means here we're gonna have figure 4, and then somewhere here we're gonna have figure 5. All right, let me write these numbers down and let's see if we can be able to analyze this. We have got 1, 4, and then 9. All right, so if you were to check whether this is arithmetic or a quadratic pattern, you would say if it's arithmetic, it must have the first difference must give us a common number, and then if not, the second difference must give us a common number if it's a quadratic. So let's see here, 4 minus 1 will give us 3, and then 9 minus 4 rather will give us 5. We don't have another number here. We also don't have another number here. So if we were to say 5 minus 3 will give us 2, but we can't say definitely whether this is quadratic or arithmetic because we can't compare with the other number that is supposed to be there. So now if you have a look at this, if you find that there's number that there's a pattern that doesn't follow any a pattern that we know of as arithmetic or linear and quadratic as well, please check this now. Check this. Check for x squared if it's a square of the numbers, maybe 1 squared, 2 squared, 3 squared, 4 squared, or check for cubic, or also check for the 4th root. So let's have a look at this one here. If you were to say 1 squared, you will have that one. 2 squared will give you this one here. 3 squared will give you this one here. Ultimately, now already you can see the pattern. You can say 4 squared will give you 16, and therefore 5 squared will therefore give us 25. So therefore it means right here now the squares, the number of squares in this figure 5 will have to be 25. I hope you can understand, guys. If you see, I'm gonna say it again, please note, if you see that the pattern does not follow either linear or quadratic, check for x squared, x cubed, or x to the power of 4 on your numbers. If you will see that they will follow one of those. All right, so now let's see. Now they said how many dots are there in figure 7. Okay, let's go ahead and count the number of dots that are there so that we don't get confused. That is 4.1.2. So let's check the number of dots here. What do we have? We've got 4 dots. Okay, in figure 1 we've got 4 dots. Here you have got how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 dots here. Here what do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 6 figures. So this is the kind of pattern that we have here: 4, 9, and therefore 16. So they want us to how many dots will be there in figure 7. So now, so this will be what? This will be figure 3, therefore figure 4, therefore figure 5, figure 6, figure 7. All right, if you ever look at these guys, you can see that starting from here, it is kind of following the same pattern. So because if you take the difference out of each other, you will see that this is neither linear nor a quadratic, but it does look like it's a quadratic, because if you see anything that is squared, it is a quadratic, which we can confirm now that we have got the fifth term. We can confirm that this is 16, and then 16 you can say 9. You can also say 16 minus 9 will give us how much? You can also say 16 minus 9 will therefore give us 7. As you can see, guys, 16 minus 9 will give us a 7. So therefore this will give us a 2 here, which confirms to us that really this is a quadratic number pattern. So therefore let's see now. So it means this was what? This was 2 squared, 3 squared, 4 squared, and then term number 4 will have to be 5. Okay, this is term number 1, this is term number 2, this is term number 3. Okay, so therefore this is term number 4. Okay, term number 4 is going to be 5 squared, 6 squared, 7 squared, 8 squared. Okay, so 8 squared is equal to 64, which simply means figure 7 here in this case will be 64. So you'll have 64 dots in figure 7. Just following the pattern, guys, nothing really hectic really. This, I think this was worth 1 mark each. Okay, 64 dots. Okay, moving right along, considering the nth figure, show that an expression for the number of dots can be rewritten as follows. All right, basically now they want us to find the nth term. All right, let's come here. 4.1.3. Somebody already said I must use a different color when I move to a different question. You can see already that I'm not a fan of doing that, but I will try to do that as many times as I can. All right, so 4.3, let's see the pattern that we have here. We have got 4 here, because they said for the number of dots, not for the number of squares. So we've got a 9 there, we've got also a 16 there. All right, so we also got a 25 there as well. So 9 minus 4 would give us 5. 16 minus 9 will give us 7. 25 minus that will therefore give us 25 minus 16, guys. Let me see. 25 minus 16. You will be surprised numerically when it comes to doing these things by head. For me, I don't stress myself, I just use a calculator. All right, 7 minus 5 is going to give us 2. 9 minus 7 is going to give us 2. What are we looking for? We're looking for the nth expression for the number of dots. So you would know, guys, initially what I already said to you. I said when it comes to quadratic, don't forget you must also be able to write 2a is equals to this term, 3a plus b is equals to this term here. Then ultimately you have a plus b plus c, which is equal to this term here. All right, which is also is equals to this term here, which is term 4. So please, guys, these first numbers on each difference means a lot. All right, so you need to know this by head. I've already said, I can't stress this enough. You need to know this by head to make life easy for yourself. You need to know that 2a is equals to the first difference 3a plus b is equals to the first number on the first difference, a plus b plus c is equals to the first original term. Please have this in your mind, guys. It is not there on the formula sheet. Okay, let's go right along, because now what does the general formula of quadratic say? It says Tn is equals to an squared plus bn plus c. What you're looking for a, b, and c. So let's go ahead. 2a is equals to 2 according to what we wrote there, divided by 2, a is equals to 1. All right, let's go. And therefore 3a plus b is equal to 5. Therefore 3, then you put 1 there, plus b, because we already know what is a. Then 3 times 1 is equals to 3. Then you take the 3 to the other side. It's going to be b is equals to 5 minus 3, which gives you b is equals to 2. All right, moving right along, a plus b plus c will give us equal to 4. You already know what is a is equals to 1, b is equals to 2. Therefore you are looking for c in this case, which is equal to 4. 1 plus 2 will give us 3. Then you take 3 to the other side. C is equals to 4 minus 3. Please let me know, guys, if I'm explaining and you can hear me, or if I'm moving a little bit too fast. Please let me know what you think. All right, so now c is equal to 1. Therefore we take a and b and substitute into our equation here, which will give us n squared plus 2n plus 1. All right, having that in mind, let's see. They said we must prove that it looks like that. It's equals to n squared plus 2n plus 1. So therefore, if you check this one, if you were to factorize this, is going to give you n plus 1 and also n plus 1. Therefore, instead of writing it like this, we can rewrite it as n plus 1 all squared. Therefore, that is the value of Tn, which we already proved just now. All right, let's move along to 4.2. If you've got a question on 4.1, please leave it on the comment section below. All right, 4.2, it says an athlete runs along a straight road. His distance d from a fixed point p on the road is measured at distance it measures at different times n and has the form of, okay, we can see already it's a quadratic pattern here. All right, the distance are recorded in the table below. Okay, in 1 second 17, 2 second 10, 3 second 5, 4 second 2. Therefore these ones we don't know, it's r and s respectively for question for say 5 seconds and 6 seconds. Okay, the first thing there, it says determine the values of r and s. Okay, so let's come here. 4.2.1. all right, so we have got 17, 10, 5, 2. okay, then we need this number and this number here, which is r and s. Okay, so 10 minus that will give us -7, and therefore 5 minus that will give us -5, and then 2 minus that will give us -3. Therefore we must continue here. -5 -7 will give us +2. -3 minus -5 will give us 2. Therefore, which means that the next question here will have to be 2 as well, which will give us this number here, which it was going to be 2 plus -3 is going to be -1, and therefore also you make another 2 there, which will say 2 plus -1 is going to give us +1. Therefore similar thing would apply here. The difference between this one needs to be -1, so therefore is going to be 2 plus that, which is going to be just 1. And also the difference between the number that is here it needs to be 2 because this 2 minus 1 will give us 1 there. So therefore it means now R is equals to 1 and therefore S is equal to 2. All right, just simple basic mathematics, guys. This one they're just giving it to us now. Straightforward, no trick about this one there. All right, and then they said next question. This is why I always stress when it comes to quadratic, you must always write here. All right, you must always say 2a is equals to that, 3a plus b is equal to that, therefore a plus b plus c is equals to that. All right, so now let's see 4.2.2. It is saying here determine the values of a, b and c, which is these values that are here. All right, so let's see dn is equals to an squared plus bn plus c. All right, moving right along, let's see. We're gonna come here. 2a is equal to 2, therefore a will be equal to 1. Great stuff. Okay, let's come here now. A plus 3a plus b is equal to -7. 3a1 plus b is equals to -7. Take 3 to the other side. B is equals to -7, -3, which gives us b is equal to -10. Right, -10. Okay, moving right along, a plus b plus c is equals to 17. We already know the value of a, which is 1. We already know the value of b, which is -10, plus c is equals to 17. So therefore, this will give us -9. 1 minus -10 will give us -9. Take -9 to the other side. C is equal to 17 plus 9. All right. So therefore this will give us the value of c as being positive 26. So that is c, that is b, and then that is a. That's all they ask us. They didn't ask us to find the equation. They just asked us to calculate a, b, and c. So now let's come to 4. Now we are moving right along. Let's come to 4.2.3. 4.2.3. And then they said, how far is the athlete from P when n is equals to 8? All right, so the distance in this case, it symbolizes by this equation right here. We already know the value of a, which means now is n squared here, minus 10n plus 26. So they're asking us what is the distance if n is equals to 8. So therefore is equals to 8 is going to give us 8 squared minus 10 times 8 plus 26, which gives us a value of, let's see now when we press our calculator, what do we get? It gives us a value of 10, what is the units? Meters. Please guys, don't forget the units. If you forget the units by any means, guys, you most likely to lose half a mark. So if they give you a unit, you write the units. If they don't give you a unit, you will just come here and say units, 10 units, because they didn't give it to you. But if they do give it to you, please guys, don't forget, write it down. All right, moving right along, let's move on to 4.2.4. Okay, interesting question indeed, guys. Very, very interesting question, and it's a nice one, this one. 4.2.4. I really enjoyed explaining this question to you guys. It's a very cool question. It says now, Mikalia claims that the pattern will have a minimum value. Jack claims that the pattern will not have a minimum value. Who is correct? Support your answer with appropriate calculation. All right, so if we are given this as our quadratic, we know that whenever they talk about minimum or maximum of quadratic, the same way they do when they talk about parabola, we need to find the turning point. All right, so in this case, it is just going to be n minus b all over 2a. So in this case, b is what? Is negative 10. There you go. All over 2a. A is what? It's 1. So therefore, this, it means that our answer is going to be 5. Okay. So therefore, it means n is greater than 0 in this case. And then it means that Malakia is correct. Michaela, I've been pronouncing this wrong. Michaela is correct. Why are we saying she is correct? Is because there is a value. Okay, if there was no value here, we got n that is less than 0, it means that Jack would have been correct. So, but in this case, Michaela is definitely correct. Let me know what you guys think. Very, very interesting question indeed. See you on the next upload. I am Gaston Mapala, where we'll be doing question 5. I think it's on financial mathematics, so you might want to watch it. Please click here on the link. The next video will take you there.